Welcome back, guys, and I do hope you and your family are keeping well. So you've done my experiment on the current voltage characteristics of a fixed resistor, and I hope you've learnt that graph. It's a straight line through the origin and it conducts in both directions, so you get a positive voltage potential difference and a positive current. You get a negative potential difference and a negative current. It goes the other way through the device. So let's now disconnect the fixed resistor and put in its place a filament lamp. That's on a little coil of wire that glows hot. So I've created another table for myself, just checking, yeah, it's working. Okay, and you might ask, Comes, why are we doing this over again? Well, we're going to do exactly the same experiment. So I've got a potential difference of 0 volts and I've obviously got no amps. I'm going to connect in and the lamp lights slightly, and I've got a potential difference of 1.42 volts and 0.19 amps. Okay, the next one, 2.82 volts and 0.26 amps. You could be writing this down as you go along, but I'll take a picture of this. 4.22 volts and 0.31 amps, and finally 5.60 volts and 0.36 amps. Okay, so we've got some readings there for the potential difference across the lamp and the current through it for different potential differences. So what we'll do now is go away, plot a graph of that data and see what you get, and we're going to compare it to the fixed resistor. Okay, so this was the next electrical component we looked at, and it was the filament lamp. I won't draw the circuit because it's the same thing over and over again. You got some data. I hope you plotted your graph, and if you haven't, pause whilst I, just after I've drawn this graph paper, these axes. So you're going to put potential difference this way, so the potential difference in volts, and you're going to put the current this way, the current in amps, and we had some positive values, both positive, and we also can take negative values as well, so we can plot those. And if you haven't done it, go and do it now, pause the video, but if not, it's done, and you get quite an interesting shape. You get this sort of thing, or something like it. Okay, at least I hope you did. It was quite a quick experiment. And if you turn the battery around and you repeat it with negative values potential difference, you get exactly the same sort of S shape. So a filament lamp conducts in both directions. Okay, it's not like an LED, which has to be the correct way around. We'll draw our curve of best fit. Okay, right. So this is going to take a little bit of explaining. First thing at GCSE is, if you see that picture, it's a filament lamp, okay? That's the graph you kind of learn for a filament lamp. Straight line for a fixed resistor, S shape for a filament lamp. Okay, something weird's happening here. If you remember, as the graph goes less steep, you're needing more volts to get amps. In other words, the resistance of this is getting higher and higher. Okay, same this way. The resistance is getting higher and higher. Okay, so the first thing I could do is say at this point here, the resistance is a lower value, and here the resistance is a larger value. So you remember Ohm's law? Okay, we can't say R is V over I. We can't say that V divided by I is a constant. Okay, if you really want to do it on your table. It would be a really good thing on your table to work out for each row across the resistance. So R equals V over I. And you'll find it won't give a constant value. It'll give a lower value to begin with, and then the resistance will get higher and higher. Okay? So, something weird's happening here. Well, the first thing you need to know is the filament lamp is not ohmic. Okay? It doesn't obey Ohm's law. And Ohm's law says that V divided by I, the ratio of V to I, is always constant. And it is in a fixed resistor. It's not in a filament lamp. So we need an explanation of that. And the explanation is quite simple. We did something we shouldn't have done. We mixed our variables up. Because here, the resistance was quite low, and the lamp was almost off. Okay, it was very, very dim. And here, the lamp was on really bright, and the resistance was higher, and it was really hot. Okay, and it's the change in temperature that we haven't controlled. It should have all been done at a fixed temperature. But that's great, because that's what lamps do. So let's see if we can explain that. Okay, low resistance when it's cold, high resistance when it's hot. It's quite an easy explanation. You think about the wire with its atoms in it and the electrons moving through the wire. They're free electrons, conduction electrons. And as it gets hotter, the atoms vibrate around a fixed point more and more and more, and the poor old electrons trying to get through get scattered. So, cold atoms are vibrating slowly, and the electrons can move through easily, low resistance. And warm atoms are vibrating a lot, and so the electrons get scattered as they try to move through the material, so the resistance goes up. I think at GCSE you probably just need to describe the fact that the resistance had increased and know the shape of that graph. Anyway, I hope that was useful. You now know a lot about the current voltage behaviour characteristic of a filament lamp. So that just leaves us to do the LED, and I'll see you soon to do that.